At first, it looked like a flawless takeoff. The Boeing 787 Dreamliner lifted off runway 23 in Ahmedabad under clear skies, fully fueled, engines roaring with over 60 tons of thrust. On board, 242 souls, including 10 crew, 2 experienced pilots, and 1 aircraft that had never suffered a total loss. But 32 seconds after liftoff, everything changed. In an instant, both engines lost power. The rat deployed. The aircraft stopped climbing. And then came the words that will forever haunt aviation history. "Why did you cut off?" Followed by, "I did not cut off." What happened in those final seconds wasn't turbulence. It wasn't weather. It wasn't mechanical failure. It was a chain of decisions, or perhaps one single decision, that left investigators stunned, engineers confused, and the world asking, how could one of the most advanced aircraft ever built crash so quickly, and so completely? In this video, we'll walk through each second, step by step, and uncover what really happened in the final moments of Flight 171. The flight crew of AY-171 followed every protocol. The 56-year-old captain and 32-year-old first officer had both rested the night before, completed breathalyzer tests, and performed all pre-flight checks. They reviewed their speeds, V1 at 153 knots, VR at 155, V2 at 162. Flaps were correctly set. The aircraft was well under maximum takeoff weight. Weather was calm, wind light. This was a routine departure from a major airport in daylight. No red flags. At 1:37 p.m. and 33 seconds, tower cleared them for takeoff. By 1:38 and 39 seconds, the aircraft was airborne. At that point, everything was still perfect. But within the next 3 seconds, a sequence began that would seal the fate of everyone on board. The left engine fuel switch was pulled to cutoff. Then, exactly 1 second later, the right followed. In the blink of an eye, both engines were starved of fuel. And while the Dreamliner could survive on one engine easily, on none at such low altitude, it had no chance. The cause? Unknown. The action? Verified. The result? Catastrophic. Once the fuel control switches were moved to cutoff, both engines immediately began to spool down. The low-pressure compressor speed, N1, and the high-pressure, N2, dropped sharply. Electrical systems began failing. 5 seconds later, the rat, the ram air turbine, deployed automatically. It was the last line of defense, supplying hydraulic power to keep the aircraft marginally controllable. But it couldn't produce thrust. It couldn't climb. And at just a few hundred feet of altitude, it didn't matter. At 10 seconds after the engines were killed, the pilots flipped the switches back to run. Too late. Engine 1 showed signs of reigniting. Engine 2 never recovered. The APU began to auto-start. But the aircraft was losing speed, altitude, and time. What had been a normal departure was now a silent descent toward a densely populated area. And the Dreamliner, engineered for efficiency, not emergency climb without power, could only glide, not rise. This wasn't a stall, this was a controlled fall, a slow, inevitable slide into the earth. With just 15 seconds left before impact, Engine 2's switch was flipped back to run. But N2 was already below minimum power generation. The computer recognized the relight command, but it couldn't arrest the deceleration. Fuel was reintroduced. Spark was triggered. But there wasn't enough time, not enough altitude. Engine 1 showed promise. The spool decay slowed, then reversed. But the climb was gone. At 1:39 and 5 seconds, just 6 seconds from impact, a pilot keyed the mic. "Mayday, Mayday, Mayday." It was too late. At 1:39 and 11 seconds, the flight data recorder went silent. Flight 171 had struck trees and a tall chimney, nose slightly pitched up, wings level. Then it collided with the BJ Medical College hostel. The wreckage tore through a 1,000 by 400-foot corridor of concrete and flames. 1 person survived. 241 others did not. Everything worked as designed. The switches responded. The relight logic engaged. The rat deployed. The APU fired. The engines tried to come back. But the one system that had no redundancy, no challenge protocol, and no override were those 2 small switches. To move them requires deliberate action, pulling up and over a detent, then down into cutoff. It cannot happen by mistake. And yet, It did. The preliminary report ruled out bird strikes, flap errors, mechanical faults, faulty fuel, excessive weight, and environmental factors. It confirmed the engines were not defective, and it did not issue a single corrective directive to Boeing or GE. So the question remains, why were the engines cut off? Was it a procedural misstep, a moment of panic, a miscommunication, or something darker? No one knows. All we know is what was said in that cockpit, in the seconds after both engines went silent. Why did you cut off? I did not cut off. That chilling exchange echoes now through every training simulator, every Boeing briefing, every airline safety department. Because the system didn't fail. It was told to stop, and it did. Investigators weren't just looking at what happened, they were looking at how it happened, and what they found was precision. Both fuel cutoff switches moved exactly 1 second apart, not milliseconds, not a random order, 1 second apart, left, then right. The same pattern used during routine engine shutdown at the gate, not during flight, not during takeoff, and never during climb out. The cockpit voice recorder didn't reveal chaos, it revealed tension. One voice asked why, the other denied it. And that denial, while emotionally haunting, made the sequence even more difficult to process. Because if one pilot had done it intentionally, why would the other have noticed and reacted so quickly to reverse it? Why did both switches move in a way consistent with a trained habit, executed cleanly, but at the wrong moment? The possibility that this was a misunderstanding between two trained professionals became even more chilling. Because when automation and precision collide with doubt, there's no time to talk it out, only time to act. And 32 seconds wasn't enough. In an aircraft where you can't retract landing gear on the ground, where flap misconfigurations trigger alarms, and where every switch is monitored electronically, you would think something as critical as cutting fuel to both engines would come with a lockout, or at least a warning. But on the 787th, it doesn't. There's no challenge confirmation logic. No, "Are you sure?" from the system. No digital interruption. Once those levers are pulled, fuel flow stops. Period. The Dreamliner's FADEC system, or as the preliminary report calls it, FADC, reacts instantly, assuming the pilot knows exactly what they're doing. And in most cases, that's true, until it's not. Investigators noted that had a simple dual confirmation logic existed, the switches could have been locked out unless the aircraft was on the ground, or at least challenged if moved in the air. But the design trusted humans more than it trusted redundancy. And in those final seconds, that trust was unreciprocated. The system was flawless, but it was silent. And silence, in that cockpit, killed. The aircraft was not overloaded. The engines were fine. The rat worked. The flaps were in the right setting. No bird strikes, no weather, no electrical anomalies, no maintenance notes of concern. Every theory failed to explain why two separate fuel cutoff switches were pulled in rapid sequence. Was it pilot suicide? The evidence didn't support it. Was it accidental? The design made that nearly impossible. Was it a procedural misstep? There's no checklist that includes that move at 300 feet. So what are we left with? We're left with a scenario that Boeing never prepared for, regulators never mandated against, and pilots never trained to anticipate. A scenario where two switches, designed for gate shutdowns, could be used, either deliberately or unintentionally, at the worst possible moment, and no system on board would intervene. The final seconds weren't chaos. They were structure collapsing in slow motion, and everyone on board watched it happen without knowing what had just begun. After the cutoff, the Dreamliner had one engine partially relit. Another remained unresponsive, but at that altitude, even full recovery of both engines wouldn't have changed the ending. The aircraft was too low, too slow, and too heavy to pull away. It clipped trees. It struck a chimney. And then it slammed into the hostel of BJ Medical College, leveling part of the building and killing 19 more on the ground. The flight data recorder captured its final breath at 1:39 and 11 seconds. From liftoff to impact, just 32 seconds. And through it all, the aircraft responded exactly as designed. Not a single system malfunctioned. The switches obeyed. The relight sequence engaged. The rat deployed. The APU auto-started. The FADC delivered fuel and ignition. But it was too late. Because the one failure the system couldn't correct was the one it was never designed to question. Flight 171 didn't fall because of a storm. It didn't fall because of a mechanical failure. It didn't fall because of negligence or a system error. It fell because two switches, just inches from the pilot's knees, were pulled. And the aircraft did exactly what it was told to do, with no hesitation, with no objection, with no safeguard. In a jet designed to prevent mistakes at every level, this was the one vulnerability that no engineer ever expected to see tested. A single act, deliberate or not, turned one of the safest aircraft ever built into a glider with no hope of recovery. The Dreamliner didn't glitch, it didn't fail, it responded, flawlessly. And that's what makes this crash more terrifying than any electrical fire, any weather anomaly, any bird strike. Because everything worked. The relight systems activated. The engines tried to come back. The pilots tried to recover. But the system wasn't built to ask why, it was built to obey. And so, in 32 seconds, the logic of trust collapsed, not because of bad code, but because the code didn't doubt its user. And now, families mourn, engineers revisit their designs, and investigators stare into black box data that shows no error, just silence. Silence where there should have been alarms. Silence where there should have been resistance. Silence where 242 people placed their lives in a system that could not and would not intervene. The terrifying final seconds of Flight 171 were not a chaotic failure. They were the sound of perfect systems doing the wrong thing, perfectly. If this story made you question what really keeps planes in the air, if it made you realize that the most advanced technology can still be helpless against a single human touch, don't let it disappear. Subscribe for more truth-driven investigations that refuse to look away.